before that, before starting the session, let's see some introduction about the InfosecTrain. Okay, basically we are the very finest and security and technology training and consulting company, and we have a 70 plus trainers. Okay, those are providing the training services as well as the consulting services. Okay, and here you will see our trusted clients. In that, we have some major clients like Tata Communications, SBI, and Emphasis. Okay, and all these. So let's get started with our today's bootcamp. As we know, the title of our bootcamp is nothing but the applied machine learning using Python. So basically, in this bootcamp, our agenda of this bootcamp is, first is Python and second one is the machine learning. These are two main topics in this bootcamp, and today we'll gonna be talk about the Python means installation, what are the different shortcuts of it, and the basics of Python. And uh, and today itself we are gonna talk about the, okay, so see here, with this download button you can just download the Anaconda for Windows, okay, or if you have different, you can say that the operating system, so you can go ahead with these different operating systems. Like you can just go and click to the download button for your respective particular operating system. See here with this, okay, from here you can easily download the Anaconda, okay, for 64-bit and as well as for 32-bit, okay, for different, for Windows as well as for Mac OS as well as for Linux. Okay, so now we'll go with the basics of Python, and before that we'll see the shortcuts, okay, of Jupyter Notebook. So basically this is the Jupyter Notebook framework, and as we know, okay, the Jupyter Notebook is an open source, okay, project created to support interactive data science and scientific computing across programming languages. And Jupyter Notebooks offer a web-based environment for working with notebooks containing code, okay, and text as well. And as well as Jupyter Notebooks are the standard workspace for most Python data analysis. Okay, so basically that's about it. Okay, so let's go, and so see, basically this is our basic Python. Okay, and here we'll talk about some basics of Python and its shortcut. So basically this is a Jupyter Notebook framework, and you can easily see, okay, we are using Jupyter Notebook for the presentation purpose. Okay, you can build the report, okay, using the Jupyter Notebook, and you can make the presentation. Okay, and see here, if you like, if you are new at this Jupyter Notebook, so basically these are some buttons, okay, from where you can just like do some multiple tasks in Jupyter Notebook. This is, okay, you can, if you wanna create some new cells, okay, in the Jupyter Notebook, so you can simply do it by with this button. Okay, or you can easily cut those, okay, extra cells, okay, from here, okay, like this. Okay, and you can easily copy and you can easily paste it. Okay, okay, with respect, okay, with the help of this, or you can just interchange the cell, okay, like this. Okay, and with this you can, with this button you can run, and like there are multiple options for running the particular cell in the Jupyter Notebook. And see here, okay, here, like I'm now using the control plus enter to run the cell. Okay, I have alternate option, okay, like this, I'm using this shift plus enter for running the particular cell as well. Okay, so basically okay, with respect to using control plus enter, okay, you will just run your particular cell in the Jupyter notebook. And if you use the shift plus enter button, so then in that case, at the end of the particular cell, okay, and there is no cell, okay, below to that particular cell. So by using shift plus enter, okay, you will run your current cell as well as you will get the new cell, okay, below to that your current cell. Okay, that is a plus point of using shift plus enter button. Or if you are let's see, and like how I created this basics of Python, the title here with respect to, okay, by using this markdown cell. First you will see here in this window, okay, we have the code word there. Okay, so means this particular cell is nothing but the code cell. Okay, if see here, if I click to this cell, so now this cell is nothing but the markdown cell. Now with respect to, like, with the help of buttons, okay, usually you can usually convert these cells, okay, from you can say that coding cell to the markdown cell. Let me use the M button to just convert this particular cell, okay, from coding cell to the markdown cell. See, okay, and by just simply by running, you will see the only, instead of getting the output of this particular cell, okay, now we just convert this code cell into the markdown cell. Okay, so that is okay, this is the beauty of Jupyter notebook. And if you want to convert this markdown cell from like markdown cell to the coding cell, so you can simply use the Y button. See, now I converted this cell from markdown cell to the coding cell. Okay, so these are few basics, so which you're gonna use in your upcoming like Jupyter notebook projects as well. Okay, and see here in the markdown cell, if you wanna just to create a title, okay, so just use this hash sign. So by using this, let's run this and see here this particular cell. Okay, after running the this particular cell, okay, here we got the title, and you can change the size of this, okay, by using this. Okay, let's run this and see. Now we just change the size of this. Okay, if you add some more, so you will get that particular, you can say that, font, okay, size. See, but here, like, I want this title here, so that's why I'm using only one hash sign, okay, to get the title. Okay, now here you can see that in any programming language, first, okay, we are starting with the hello word. So here as well, okay, we are using the hello word, just same, you can say that same code, print hello word. And with respect to this, okay, by running this particular cell, we got the output as a hello word. Okay, so basically this is a one Jupyter notebook framework you can access with the help of Anaconda. Okay, and in the Anaconda navigator, see here, so if you install Anaconda, so in that Anaconda, okay, you will get these many features like Jupyter notebook, spider, okay, and you may get R Studio, Orange. Okay, likewise we have so many different uh, like wave frameworks. Okay, so let me open the Jupyter uh, Anaconda navigator, and then we'll show you what are the different web frameworks are there. Okay, so like for this particular Jupyter notebook, so you can see how we just like use the different shortcuts, okay, for like type the code in fast manner. And basically you see here we are accessing the Python programming language from here. So as we know, Python is a very popular programming language, and basically it was created by Gordon Wasson, okay, and released in 1991. And as we all know, we are using Python for various purposes, like for web development, for for creation of gaming, as well as for software development, as well as for mathematical modeling, as well as for data science, artificial intelligence, and there are many uses of Python. Okay, because with respect to, like, with the help of Python, we can easily access the different features of Python by using the different libraries. Okay, okay, okay. So see here, first, after creating this like hello world, first in Python, first step is very important step, is nothing but the indentation. So see here, I'm just creating the if statement, and in that if statement I'm just mentioning one condition here, okay, or one argument here, which is 5 is greater than 2, which means if this particular condition is true, then just print this particular statement, which is nothing but the 5 is greater than 2. Okay, and basically, for, like, in if statement, I use this a block, which is a, you can say that, a simple uh, blank space, okay, or a simple block. Okay, so with this, okay, I'm able to run this if statement. See here, okay, here I got the output. And if I just you can say that, let me just cut this, and if I'm not using this particular indentation here, or the block of white space, and let me run this cell particular, so see here, then definitely, okay, I'll get the error, and the error saying that this is the indentation error. Okay, means here we don't have any indentation block. Okay, and from that particular block you can easily run your code, okay, in the statement or in the loops format. Okay, so first thing is nothing but the indentation. Okay, and this is a very basic thing in Python. And see here, we have to provide a small block of indentation, okay, always there in the statement as well as in the loop. Okay, see here, I am first creating the one indentation here, which is nothing but the with the help of if statement, 5 is greater than 2, and if this particular argument is true, then just print this particular statement. Okay, and again I created second if statement, which is saying that if particular this algorithm 7 is greater than 4, then simply print this statement. So basically I use different block size here. Okay, so let me run this. So see, if I'm using this different block size, then only I'll get the answer or output, because here also I mentioned the block, here also I mentioned a simple block. Okay, so that's why I got the output for these two if statement. Okay, and if, like, I want to get the multiple outcomes from this one if statement, so for that purpose I need to mention same size of blocks of indentation, but here I mentioned the different sizes of blocks. See, so first let me run this particular cell and see in this particular cell. Okay, here we also got the error, which is saying that indentation error, unexpected indent. So that's why if I just remove one indentation block, okay, and I just make this the indentation with same sizes, so see, now we can able to run this particular cell. Okay, so these are like some basics of Python, which are very basic terms, and these are very important things. Okay, if you want, just if you want to be a developer or a data scientist, so for that purpose you need to have a good command on your programming skills. Okay, and see here, basically I'm using in the coding cell the hash sign. So with respect to, like, with the help of this hash sign, okay, I'm able to just make that particular line of code into the comment. Okay, see here, I'm using this hash sign to just making this particular line of code into the comment. Okay, so see, or you can just add that particular statement of explanation of your particular code, okay, with the help of hash sign in the coding cell itself, instead of by just creating this any one markdown cell. Okay, instead of coding cell. See here, we have so many different uh, like cell options, like markdown cell, heading cell, okay, raw and beacon word. Okay, likewise. And see here, you can mention your comment, okay, above to the cell, or after the cell, or below to the cell, okay, in the coding cell itself, with this, okay, with the help of just by adding one hash sign, okay, before adding the comment in your particular coding cell. And see, you can not only just add a comment or a sentence in your coding cell by using the hash sign and creating that particular cell into the comment, or here see, I just convert that this particular code, okay, into the comment by using the hash sign. Okay, like many a time, okay, you're gonna just type many codes, okay, which are alternative methods as well in data science or in AI or in machine learning. So for that reason, okay, you have to go with only one method. Okay, so for that purpose, okay, you can use this hash sign to just make that particular your alternate method into the comment. See, or in Python, you can add a multi line of comment as well. See here, first you can just use this to just create your multi-line of comment with the help of this hash sign, or you can just use the three double quotes or the three single quotes to create the multi-line comment. See here, I use three double quote to just convert this three line, okay, into the comment. See, so this is how you can able to create, or you can able to make the comment in the coding cell itself. Okay, now here let us see the different variables of Python. So basically variables are nothing but the containers, okay, for storing different values, okay, of different types. So see here, first, this is a x variable, okay, and I'm using this particular x variable to store this value, okay, which is a 5 value. Now I use again the different variable, which is nothing but y, and see here, I'm storing this string. Now basically the type of these two variables are different. So first variable's type is nothing but the integer, another variable's type is a string, because the text, okay, in Python, we can say that the text in Python is nothing but the string, and you can get the like output of this each and every value in the Python with the help of print method. So see, this is how you can get the output, okay, with the help of Python, with the help of print method. And see here, basically, if you are not using the print method, so simply you need to just mention only one outcome at a time, or a one variable name at a time. Okay, then only you will get the outcome of your like answer. Okay, otherwise, see here, like I mentioned the two variable name, okay, which I just import or load in my Python. So see, I just use X and Y here. So let me run this and see here. I got the output for only Y variable. Okay, because here I haven't used the print method. So that's why I got the output in, okay, for Y only, not for X. If I use this thing, okay, first Y and lastly X, okay, then I got the output for X variable only, not for Y. Okay, so that's why we have to use print method for getting multiple outputs, okay, at the same time. So see here, now I just use a different value for the same variable. Let's see here, I just use a variable X and I'm storing this 4 value in the variable X. Again, I'm using the same variable name and I'm storing this value, okay, this string value, and see, I'm printing the okay, outcome. So see, okay, so first for print, okay, I got this outcome. For X, I got this outcome. Okay, so see the difference between like the outcome for the print method and for only X. Okay, and see here, if you mention or if you add the two different values for the same variable name, then definitely the variable just consider the last value. Okay, and it will store the last value, okay, according to like to that particular X variable name. And see here, we can convert the different data types in Python by using this. Okay, let's see, this is the 3 value, okay, and as we know, this is the integer. Okay, 3 is the integer. So in Python as well, okay, the type of this value is nothing but the int, means integer. So I'm converting this 3 means in this data type, this values data type, from integer to string by using this str, means struct method. And see here, now this is a floating point number, or in Python you can just say that this is only float. So I'm converting this float into the integer. And now see here, this is an integer, I'm converting this into the float. Okay, let us load let us store these values, okay, and use these methods to convert the data type, okay, in Python. And let's print the output, and see, the output is nothing but the, see, this is the output with the help of print method we got here. And see here, now this is not the integer, okay, the type of this is nothing but the string. Okay, see here, the type of X is a string. See, now we just convert the type. Now this method is nothing but the casting method. Okay, now you can print the types of your means data type of your variable X and Y, okay, with the help of print method as well. So see, I use just type method, and okay, and I'm using print method to type the data type of that particular variable, which is nothing but the X as well as the variable Y. So see here, the data type of X variable is integer and the data type of Y variable is a string. Okay, and this is the same thing. See, for like for storing the value of string, okay, in Python, see, first I can use the double quote, okay, to read the string value, or I can use the single quote. Okay, this is a subjective choice for choosing this double quote or the single quote. Okay, but the you will get the outcome for both the variables. See, okay, so this is how you can just add your string value in Python. by using the double quote or the single quote. And again, Python is a very case sensitive language. Okay, so that's why see here, if I use a variable a which is in a small case, and I store the value of this small a equal to 5 and the capital A equal to 6, so then see here, okay, the outcome of this small a is 5 and capital A is 6, because Python is a very case sensitive language. Okay, means here my intention is to show you that if you have different column names, okay, like let's say the expected salary, okay, in a lower case, okay, and again you have the same column or the duplicate column in your data with uppercase in the, like the same name with the in the uppercase as a expected salary, so those two columns are same, but here, but for the name only those two columns are different. Okay, so you can access each column by using the column name, okay, in the lower case as well as the uppercase. Okay, and see here, this Python is a case sensitive, that's why this capital A will not overwrite small a. Okay, see, I just use the print method, okay, to get the output for both the variables. Okay, and see, the output is different. And now, like in Python, there are some you can say that some condition to write the variable names. Okay, you can use the underscore or the capital letter or the small letter, okay, at the initial of the variable name. Okay, then only you will get the, like the output for that particular variable name. Let's see, if I use the underscore and the later, any letter, and I store this 5 value for this particular variable name. Okay, so see, I'm able to run this particular cell. Okay, because, okay, I use a legal variable name. Okay, if I use this number, okay, at the starting of this variable name and then later particular, okay, you can use any different letter, and let me run this particular cell, and definitely Python give us the error, because here see, the error is nothing but the syntax error. Okay, here we can't use the number at the starting of the variable name. Okay, because Python, okay, for creating variable names in Python, okay, we have to just like we have some constraint, like a variable name must start with a letter or underscore character. Second thing is that a variable name cannot start with a number. Means you can simply say that in variable name can only contain alphanumerical characters and underscore. Now here, as you see, you can't use any number at the starting of your variable name. Okay, but after that you can use the number, okay, from 0 to 9. Okay, see here, I just mentioned the a3 which is equal to 5, so a3 is nothing but the variable name, so I store this 5 value with the help of this variable name. So here I'm able to store this 5 value with this variable name. Okay, so you can say that here, okay, these variable names are the legal variables name. Okay, see, so you can use the underscore character or the any letter at the starting of variable name. But see here, I use a letter at the starting of the variable name, but here I mention a minus sign. Okay, so let me run this, and here you can see that this is again syntax error. Okay, cannot assign to operator, because here we just use this particular symbol for subtraction purpose in Python. So that's why here we can't use this particular operator, okay, to just mention the particular variable name. Okay, and see here, like if you have a different column names in your data, like a small like in small case you have a column name as a age, and in that data, in the same data, you have another variable name as like age with different value. So definitely those two columns are the different. Okay, like this. Okay, I store the 6 value by using this variable name, okay, which is nothing but the age. And now I am using this age word, which is a bit different than this word, because the first letter is a capital one here. Okay, so definitely here I got the error. Okay, so see here, definitely we'll get the error here, because here this variable name is not mentioned here, or we haven't used this variable name, okay, about to this code. Okay, see, name error. Okay, name age is not defined. So here case sensitiveness is very important in Python. So see, these are some, you can say that, legal variable name, and see, these are some are illegal variable name. Okay, so let me run this cell and see, we can able to run this particular cell. Okay, but we can't run this cell. Okay, we cannot run this cell, because definitely, okay, this is nothing but the syntax error, as well as this is also the syntax error, and here as well. Okay, we'll get the error, because here we haven't used the legal variable name. Okay, and see, now after that, now in many cases you will see, like when you will be working with any company, so in this like in that company, so they'll be providing you the data set for the data analysis purpose. So you, okay, then you will find that in your data there are multiple columns with the name as a multi-word, okay, column name. Okay, like in the sensor data we have the multi-word column names. Okay, so now to just define multi-word variable names or the column names, we have different types or the different cases. Okay, let's see here. Here this is the first case, we can say that this is a camel case. Okay, one type of creating multi-word variable name. Okay, so basically in the camel case, each word except the first starts with a capital letter. So see, each word except the first word start with a capital letter. So see, this is one word, okay, in this particular multi-word variable name, and this is another word. Okay, so let me run this, and now this is the another case or the another type of mentioning multi-word variable name. So see, basically this is nothing but the camel case, in that each word starts with a capital letter. So see the difference between the camel case and the Pascal case. And lastly here, see, from these three types we can easily read this variable name, okay, which is a multi-word variable name. How? Because I add the underscore character, okay, between each and every word. So see, this is nothing but the snake case. Okay, so here instead of using, okay, it's a choice, it's a subjective choice of using different case. It's up to you totally, but I'm preferring this particular case. Okay, and see here, in Python you can able to add the multiple variable names for multiple your outputs. Okay, see here, I add three variable names for three different outputs, and with the help of print method I can able to get the output. Okay, see, or you can mention, or you can add a multiple variable names to one output. See here, see, I use the xyz variable name for this particular one output. Okay, and here you can see that now from here we'll see how to add the two string values. Okay, basically as we know we are adding two different values or two variables, okay, with respect, okay, with the help of plus sign. Okay, this is the, you can say that the addition operator. But for adding two different variables, these two different variables the should be the same data types. Okay, then only you will able to add those two variables. Okay, see here, this is my first variable and I'm adding this variable with this. Okay, and as we know that if I'm just finding out the type of this particular string value, so as we know this is a string. Okay, and here you can see that, okay, I just use a variable x to store this particular word, which is awesome. Okay, with the help of this addition operator I can simply add these two strings. Okay, and you can just add these two like two different variables as well with the help of addition operator, because the types of these two x and y variables are nothing but the string. Okay, and see here, now I'm just adding the two values which are numerical one. Okay, the type of these two variable is nothing but the integer, and in simple words I'm using the addition. Okay, the addition operator for adding these two values. See, but now you can see that first I just created one variable which is variable name as a 5 x with the value as a 5, and the data type of this variable is nothing but the integer. And see here, this is a variable y and I store this John value here. Okay, in the variable y, and now I'm using the casting method to convert this data type, okay, type of this variable from integer to string, and I'm using the print method, okay, to get the output. So see here, with the help of casting method we can easily add the two different types of the variables. Okay, and again see here, as we know we can find out the type of the variable with the help of type method. Okay, so you can see that the Python code is very similar to the English language. Okay, so that's why many people are just preferring Python. Okay, and now we can get the different types, okay, of the variables, see, by using the type method. Okay, so in the numbers in Python we have three different types. Okay, first one is the integer, second one is the float, and third one is a complex. Okay, so these three are the different, you can say that the types, data types in Python for particular number. Okay, and as we know, for the, you can say that for the text value, okay, you have the string data type. Okay, special. And for creating the complex value, okay, any complex value, here you in Python this j later is just you can say that just mention. Okay, you have to use this j later for creating the complex number. Okay, if you use the like I word, okay, like many time in mathematics we are using a plus bi. So basically this is nothing but the complex number. Okay, I, value of I is nothing but the square root of -1. But here in Python, this j letter is reserved for this particular creating the complex number. So that's why instead of using I, here I am using j letter for creating the complex number. Okay, and you can just get the types of your variable. So see the different types. Okay, and you can get the type of your variable. Okay, whatever your number is. Okay, and how much is big. Okay, no matter. Okay, with the help of type method you can easily get the type of your variable. See, and
Why we get output as class?
because like in type method, okay, like behind this method, okay, they just created one class, okay, to get the output. Okay, so that's why here we have mentioned the class method. Okay, so basically this is like in the object oriented programming in Python. Okay, we are using this class and objects. So like with the help of opp, means object oriented programming, we just created this type method, which is the inbuilt method. Okay, and we are using this method to extract the output of this particular variable. So that's why we get the output, okay, in terms of classes. And see, this is the answer. Okay,
Yeah, thank you.
and see here, this is a floating point numbers, or you can simply say that float. Okay, and see here, with the help of again float, you with the help of type method, here see we are getting the type of the different variables. And see, this is how you will get the different like again the data types. And see, for creating like for adding a type, okay, of your variable. So see here, I mention the one sentence here, and here the type of this particular variable is nothing but the string, because here I load the text data. Okay, and see here as well. So basically many time we have to use the exponential term is there. Okay, so as we know, like the value of this exponential term, this is a 2.71. It's not the exact value, it's the appropriate value. So see, so all these three values are the type of these three values are nothing but the float. Okay, and after that, see, we can easily get the like the sub you can say that subsample from your string value. Okay, so see, basically we have this one hello world text. Okay, and like I want to extract this value with respect to this index x, okay, from 2 to 5. Now here 5 is excluded. So basically in Python, index start with 0, and we are not taking the like the last index into the account. So that's why 5 is not 5 is just excluded here. Okay, so let us run this and see the output. Basically, as we know, the index of h letter is 0, index of e letter is 1, index of l letter is 2. So that's why from 2, 3 and 4 we got this three letters, means we are able to extract the any specific letter or the word as well from the string value. So this is nothing but the slicing method. Okay, now there are multiple types of the slicing method, like the slice from the start. So see here, I just mentioned the last index value. So this is nothing but the slicing from the start. Okay, See, so here I got the hello, only the single word. Okay, means here you can see that the index of h word is 0, then 1, 2, 3 and 4. 5 is excluded here, so that's why we got this output. Okay, and now this is another type of slicing, which is nothing but the slice to the end. Okay, so from index 2 I want all the letters. Okay, so see, this is how you can slice your data, or you can extract your data with the help of slicing. Okay, and this is nothing but the index negative slicing. So see, this is nothing but the, like, for d letter, this is a -1 index, and this is a, here you can see that -2. Likewise, this is a negative slicing is there. Okay, or negative indexing is there. Or now we have many inbuilt methods from, okay, with the help of these many different methods, you can easily modify your string data. Okay, see here I'm using the upper method. So basically I just created one variable which is a hello word, and see here I'm applying upper method on this variable. Okay, so means I want to convert this hello word from from this to the, like, the uppercase. Okay, means I am converting each and every letter in my string into the uppercase. You can convert your text or the string value in the lower case as well by using the lower method. Okay, then you can use the case fold method. See, we are using case fold method to get the output, okay, like this. Okay, in the, you can see that the lower case. Okay, and see here, this is nothing but the strip method. Now strip method is very much important, because many time you will see, like, okay, in the real life data set, when we are dealing with the text data, okay, we'll get the many extra spaces which are like blank spaces in our text data. Okay, so for removing those extra spaces, okay, we can use this strip method. So, and we are using this step method in the natural language processing, which is you can say that very important application, okay, of artificial intelligence. Okay, see, we just remove the extra blank spaces, okay, with the help of strip method. Or with the help of replace method, you can able to replace any word, any particular letter, okay, as well. See, I just replace the L letter by J. See, likewise we have so many different inbuilt methods. See, and you can see here, now we have another method which we are using in the natural language processing. Again, this is another method we are using for the like in the natural language processing. Now basically, like, as we know, if we have a lot of data, okay, in the text format, so like we have to convert those data into the numeric data, okay, to apply our like machine learning techniques on them. Okay, so like for that purpose we have to pre-process the data. So at that time, okay, we have to use this split method to convert the one line of statement or the one paragraph, uh, okay, into the list of words, or you can say that the bag of word. So for that purpose you can use this split method. Okay, see, now we just convert this particular statement or the string value into the list of words. See, this is a list, and you can use this, the particular separator as a blank space. I use here a blank space as the separator for creating or for splitting the data. See, I just split this particular sentence into the list of word or the bag of word. Okay, so these are multiple, you can say that the multiple, we have so many different inbuilt methods like the format method, and we have all different stuff there. Okay, so we'll share this particular code, okay, with you as well. You can go ahead with this. And now we'll go with the linear regression, okay, which is our today's topic. Okay, so before going to the linear regression, first let us discuss about the important, you can say that the libraries of the machine learning. Okay, so basically, as we know, we have so many different libraries in Python which are very important for machine learning. Okay, and see, this first is nothing but the pandas library. As we know, okay, apparently, like pandas, we are using pandas library for the data pre-processing, for the data wrangling purpose. Okay, and basically it is a library for tabular data structure, for data analysis and the data modeling tools. Okay, and we can able to plot, okay, means we can able to create this different plots. Like in the backend we are using the matplotlib library here. Okay, as well. And basically pandas library is for the data analysis. Okay, that's it. Then we have another library which is nothing but the numpy library. Okay, so basically again numpy library is nothing but the very again second popular library for creating the n dimensional array. As well as here with the help of numpy library we can able to like do some statistical data analysis stuff. And here with the help of SkyPy as well as the NumPy, okay, we can able to use this for linear algebra and other different operations. Okay, like especially SkyPy, we can use this for optimization as well as for linear algebra as well as in statistics. Okay, then we have another library which is nothing but the Seaborn library. Okay, again we are using Seaborn library as well as the matplotlib library for the data visualization library. Okay, then we have the stats model library. Basically we are using this library for conducting many statistical tests. Okay, as well as statistical data exploration. Okay, and we can able to like get the ordinary square method for like by using this particular stats model library. And we can get the summary, okay, of the regression model, okay, for this stats model library. And the summary is very good. Like in that we got the will get the r square value, adjusted r square value, means many parameters will get, okay, with the help of stats model library. And lastly we have the sklearn library. Like those who are working in the machine learning field, so those who know that sklearn is nothing but the very famous library for machine learning only. Okay, we can able to extract each and every algorithm of machine learning by using sklearn library in Python. Okay, or we can even use this sklearn library for splitting the data. We can use this library for pre-process the data. Okay, we can use the library for like getting the different evaluation matrices, like our classification report, confusion matrix, okay, in okay, in Python. So see, uh, if you are the beginner, okay, so you have to learn this all library. Okay, then only you will understand or you will able to like get the different data. Okay, or you can analyze different data, or you can apply different machine learning algorithms on your data. Okay, now what is machine learning? Basically it is the science of getting computers to act without being explicitly programmed. Okay, in short, like we have the data. Okay, we are using Python language or any different programming language, okay, to apply any machine learning algorithm on the data. So basically we use data, okay, we just load the data into the computer and we apply machine learning technique, okay, and that from that, okay, the the system give us a model, okay, and that particular model of machine learning we can able to make the predictions for the new data set, okay. So see here, basically, as we know, machine learning is a subset of artificial intelligence, and like machine learning is the area of computational science that focuses on analyzing and interpreting patterns and structures in data to enable learning, reasoning, and decision making outside of human interaction, okay. And machine learning allows the user to feed a computer algorithm an immense amount of data and have the computer analyze and make data driven recommendations and decisions based on only the input data, okay. If any corrections are identified, the algorithm can incorporate that information to improve its future decision making, okay. So as we know, like this is a very like hot topic, which is a machine learning, and like many industries are just implementing this, like just using machine learning to find out the very important insights from the data, okay. So you see, basically for machine learning we need data, okay. So basically we can say that data is the lifeblood of all businesses, okay. And data driven decisions increasingly make the difference between keeping up with competition or falling further behind, okay. So machine learning can be the key to unlocking the value of corporate and customer data and enacting decision that keep a company ahead of the competition, okay. So here you will see that in machine learning, okay, we are solving many different types of problem, okay. So see here, there are three main, you can see that three main types of machine learning, okay. First one is the supervised learning, second one is a unsupervised learning, and third one is a reinforcement learning, okay. So in this boot camp we are going to talk about regression, classification, and clustering as discussed, okay. So see here, as we know, the unsupervised learning basically it describes a class of problems that involves using a model to describe or extract relationships in the data, okay. And it operates upon only the input data without outputs or target variable, okay. Let me clear this part, okay. So before that, okay, see, uh, there are different types of unsupervised learning, okay. So here you can see that, let me just use the pane, okay. So see, in the unsupervised learning basically we are dealing with only input data. Now what is input data and what is output data here? So basically in the data set, okay, like we have the variables, sorry, wait, okay. So see, we have the, it's not working, okay. So I think it's not working, okay. So see here, basically like as we know, we have the input data and the output data in our data. So means like we are creating the model, okay, by using the data. So in our data we have some columns, okay. With the help of those column we are building the model, okay. So those columns are nothing but the input data, okay. And in that data we have the one column, okay. We can say that that particular column is nothing but the output or the target column, okay. We are building the model for that particular output or the target variable by using all the remaining columns in our data. So you see, the first input data is nothing but we are using those particular column for creating the model, okay. So that particular, those all columns, okay, are nothing but the input data. And target data means we are creating the model for that particular target column, okay, to predict that particular target column, okay. And in the unsupervised learning we have different techniques, okay. Like first we have the clustering technique. Basically we are using clustering technique to create the groups in our data, okay. Second, we have the dimensionality reduction technique. So basically we are using this technique to reduce the dimension of the data, okay. Means let's say suppose in real life data set, okay, we may get thousands of column in our data and millions and trillions of rows in our data. So in that case our system is not that much capable, okay, to analyze those amount of that huge amount of data. So in that case, okay, we have to use the dimensionality reduction technique, okay, to reduce the dimension of the data, okay. So we have so many different techniques, okay. And with those techniques we can easily reduce the dimension of the data, and then we can able to do the further analysis, like we can able to apply some machine learning algorithms. And finally we have the association rule, okay. So basically association rule is we are using this rule for like in the recommendation system, okay. So as you know, the word recommendation is there. So basically, like let's say we are just go to the YouTube and we are searching for a particular video, okay. And we just watched that particular video. So along, like by searching that particular video, okay, with respect to the name, so you see, so after getting that original video, okay, we'll get different videos, okay, different videos, but which are very similar to your topic. So see, those remaining videos are nothing but the recommendations to you, okay. So those recommendation is possible because of association rule, okay. Or you went to the, like if we go to the any supermarket, so in that supermarket you will see that in the one shell, okay, there is always, okay, a like where we get the butter, okay. So like along with butter we have the bread as well, okay. We'll get the milk as well, we'll get the banana as well, because we are frequently buying those item, okay, together. Because see here we are using milk, bread, butter, okay, those kind of thing, okay, for our like for the breakfast purpose, okay. So you see, there is some relationship between those attributes, okay. So we are using association rule to find out those kind of rules, okay, those kind of relationship between the different products. So then we can like the e-commerce company or the supermarket can just find out those relationships, okay, by using our past data, past purchase data. And they can easily find out this relation, and they will definitely like gain the more customers, as well as they will increase their sales as well, okay. Then we have another supervised learning, okay. This is the another type of machine learning, and basically this type describes a class of problem that involves using a model to learn a mapping between input variables and the target variables. Okay, so now in the supervised learning, basically we are dealing with the data set. We can say that label data set means in that data set we have input variable. You know what are the different input data is? So input variables are nothing but the one variable in the input data. Okay, output variable or the target variable is nothing but the target column, okay, in your data. So here you are using both the two input data as well as the output data to create the model. Okay, so see here in the supervised learning, basically we are facing two types of problem. Okay, first one is the regression, another type is a classification. So see, in the regression we are just predicting a numerical label. Okay, for example, house price prediction, or the share market like share price prediction, or the gold price prediction, or the like today's temperature or the tomorrow's temperature. Okay, means we can able to predict a numerical value. Okay, or you can say that numerical label. Okay, so that type, okay, is nothing but the regression type. Okay, or another type is a classification one. Okay, you can able to make the prediction for your class label. Okay, now what is class? So basically in your output variable or the target column, okay, you have the classes, okay, instead of numerical value. Okay, let's see. Okay, first you have the data for any you can say that for your customers. Okay, and you're gonna find out that particular customer just purchased your particular product or not. Okay, by using their expected salary, by you have that customers information like age, expected salary. Okay, then their qualification and all the details related to your customers. Okay, and you wanted to find that particular customers will gonna buy your product or not. Okay, so now here, see, here we want to build a model for checking that particular customer is buying your product or not. Okay, means yes no type of outcome is there in your target column. Okay, so this is a classification problem. So uh, very basic and very popular example of this classification is nothing but the MNist handwritten digits data set. Okay, means here you have to classify the different handwritten digits. Okay, as we know there are total digits are 10 from 0 to 9. Okay, and here in this data set we have total, let's say for training we have 70,000 data set, for testing we have 30,000 data set. Okay, or the images of the handwritten digits. Okay, and here our aim is to build a classification model for making the prediction or for finding that particular image is from which digit. Okay, is of which digit. Okay, from 0 to 9. Okay, so those type of problem you are facing in the supervised learning. Okay, so basically you are building the model in the supervised learning, that's it. Okay, now let us talk about machine learning use cases, means the applications of the machine learning. Okay, as we know, as we are using artificial intelligence in each and every domain, so machine learning is a subset of artificial intelligence. Means in short, we are using machine learning in each and every domain. Okay, so these are some main domains, okay, which we are using machine learning aggressively. Okay, so in the manufacturing domain, okay, we are using machine learning for predictive maintenance and condition monitoring. Then in the retail domain we are using machine learning for upselling and cross channel marketing. Then in healthcare and life sciences okay, in this particular domain, okay, we are using machine learning for disease identification, okay, as well as the risk satisfaction, okay, satisfaction. Then in the travel and the hospitality domain, okay, we are using machine learning for finding out the dynamic pricing, okay. And in the financial services, we are using machine learning for risk analytics and regulation, okay. And in the energy domain, okay, we are solving the different type of optimization problem depending upon the demand and supply kind of problem, like the transportation problem, assignment problem. So that's why as well we are using this machine learning, okay. So basically in cyber security as well, we are using machine learning. Now in cyber security, let's say credit card fraud, okay. So okay, you are like seeing that like nowadays, okay, there is like a lot of fraud is going on for like online fraud, okay, we can say that. So those we can able to detect those online fraud, okay, with the help of machine learning, okay. So this is nothing but the one algorithm, very famous algorithm of machine learning is there, okay, for detecting those kind of frauds, okay, which is nothing but the anomaly detection, okay. So with the help of anomaly detection, we are able to like find out, or we are able to detect those kind of frauds. See, yes, definitely we are using cyber security in like we are using machine learning in cyber security, see. And now here, okay, let's talk about the regression analysis. So basically, for understanding the regression analysis, first we have to check that, or first we have to know that why we are using regression analysis, why we are applying regression analysis for like on our data, okay. So as we know, we are using regression, okay, to make the prediction, okay, for the numerical outcome. See, so scatter plot is one of the visualization type of like checking the for visualizing numerical data, okay. So basically see here, there are a lot of scatter plots, okay, and they are showing different types, okay, of the scatter plot. So if our data points, okay, those are, we can say that the numerical data points, and if we plot those like two columns of our numerical data times, okay, with the help of scatter plot. So see, if the data is looks like this, so we can simply say that our data is going in a upward direction, and now it is just making the one single line, the straight line, okay. And here you will see the data points are very close to each other, okay. Means there is no variance, there is no scatterness present, okay, in the numeric data. So you can say that this is nothing but the strong positive correlation, okay. So basically correlation is nothing but the, you can say that the we are using correlation, okay, for finding out the linear relationship between the two columns, okay. So for that purpose we are using the scatter plot for checking the which type of correlation is there in between the two columns which are numeric, okay. And if our data points are going in an upward direction, but they are just showing that there is a moderate scatterness present in the data. So in that case, you can say that there is a moderate positive correlation, okay, or moderate positive linear relationship between two columns, okay. So, and sometimes your data may look like this, okay. So you can say that your two columns are like there is no correlation between two columns, okay, or two variables. So in short, you can say that there is no correlation. Okay, then if your data going in a downward direction with moderate scatterness present, so you can simply say that now the type of this scatter plot is nothing but the moderate positive correlation. Okay, and here you will see your data points are going in a downward direction, but they are very close to each other. Okay, and they are going in a downward direction in a one line. Okay, so see, then you can say that there is a strong negative correlation. Okay, and sometimes your data may looks like may just create a non-linear relationship. Okay, by looking at this plot you will see this kind of plot is there. Okay, so means you can see that there is a non-linear relationship or the curvilinear relationship. So see, in this plot only we use the term relationship. Okay, but in this remaining plot we use the term correlation. Why? Because we are using correlation, okay, to find out the linear relationship. Okay, and here in the non-linear relationship, basically here, okay, we got the non-linear relationship na? So that's why there is no correlation. Okay, simply relationship. Okay, so that is the difference. Means many times interviewer may ask you about this correlations question. Okay, why we are using this correlation. Okay,
Kapil, one quick question.
yeah,
Yeah, in the last slide, how many input we need to feed to the scatter plot?
actually like I created this scatter plot is to show you the different types of the scatter plot. Okay, there is like you can say that here we just use the different like number of data points, okay, to create this. But you can create the scatter plot by using any number of data point. Okay, you can even create a scatter plot by using only two data points as well. Okay,
Yeah, in XYZ graph, we use only two inputs, X and Y. Based on that, we keep on, yeah, we get the output. So here there are multiple input and multiple output, right?
yes, multiple data points, but here we are
Right.
just using the two columns, okay, in from the data set. Okay, not
Got
xyz, we just use the two columns, and from that two, okay, in that two column we have so many outputs, so many rows, okay, in the data set. So
got it, got it.
like likewise
Thank you.
you can just create the scatter plot. Now here see, there is a correlation coefficient is there. So see, basically we are using correlation coefficient to measure the degree of linear relationship between two continuous variable. Okay, or you can say that two numerical variable. Okay, and see, this is a formula for finding out the correlation coefficient. Okay, basically like those like some people may are from may from the statistics background. Okay, they will understand this thing. Okay, cov xy means this is nothing but the covariance of x and y divided by standard deviation of x with respect to your x data, standard deviation with respect to your y data. Okay, this s is for is stands for the standard deviation. Okay, and this is how you can find out the correlation. Okay, so basically correlation is a one value which is lies between the -1 to +1. Okay, +1 you can say that there is a strong positive correlation, -1 means there is a strong negative correlation, and 0 means there is a no correlation. Okay, you can even go ahead with this formula, okay, to find out the correlation coefficient. Okay, and just remember that we are using correlation coefficient to just find out the degree of linear relationship, not the non-linear relationship. Okay, so now let's talk about linear regression model. Basically we are creating this linear regression model, okay, to make the prediction in terms of numerical values. Okay, So as we know, sometimes we may have only two columns in our data. Okay, one is nothing but the input column and another is the output column. Okay, as we already discussed about it, like see here, this y variable is nothing but the outcome column, okay, or the output column, or you can say that the target column. Okay, this for particular y, okay, we have so many names. Okay, you can say that this is a dependent variable, this is a target column, output column, this is a response column. See, and for this x variable, okay, we have so many different names as well. Like this is nothing but the independent variable, this is nothing but the regressor column, this is the this is the explanatory column, again this is the predictor, this is the input column. Okay, likewise we have so many name for this x. Okay, so this first equation, we use this equation for like in the simple linear regression. Okay, so basically if we just remove this epsilon sign, okay, so can you guys tell me this particular equation is like we use this particular equation for something, so can you able to tell me for what purpose we are using this equation? Okay, anyone? Okay, if you remove this epsilon, okay, anyone? Okay, so basically this is the equation of line. Okay, ax plus b. Okay, y equal to means c equal to ax plus b. So this is the equation of line. So simply here in the simple linear regression, from one column, okay, we are just making the model for predicting another column. Okay, so this is here we have one equation of the simple linear regression. Now in the same way, okay, or just the expansion, if you have the multiple x columns or the input data, okay, in your original data, so see you have x1 column, you have x2 column, you have xk column, as well as you have y column. Means you are using x1 x2 xk columns for building the model. Okay, and with the help of that particular model, this model beta naught plus beta 1 x plus beta 2 x2 plus so on, plus beta k x k plus epsilon, with this particular model, okay, we are able to make the predictions for this particular y value. Okay, for this y value or the column. So see, beta naught, beta 1 and all these beta values are nothing but the parameters of the model, or you can say that coefficients of the model, and epsilon is a error term. Okay, because here in real life we are just dealing with a real life data set, so that's why error is always there. So that's why I add one term there, epsilon. Okay, now you see, okay, we have the data points. Okay, these blue data points are nothing but the actual data points. Okay, and I plotted this scatter plot, and as well as I find out the regression line, okay, by using the least square method. Okay, basically this is a method for finding out the coefficients of this beta naught and beta 1 of the regression, this simple linear regression equation. So by finding out this y equal to beta naught plus beta 1 x, okay, I simply plotted this line. Okay, so after plotting this line, so basically this beta naught is nothing but the intercept. Okay, so many time this is a very important interview question: what is the interpretation of coefficient of your regression model? Okay, so see here, beta naught and beta 1 are the two parameters or the coefficients of this particular equation. So beta naught is the initial value of your y. Okay, means if x equal to 0, then y equal to beta naught. So this is nothing but the intercept, means at which point this your regression line just intersecting to the y-axis is nothing but the beta naught. Okay, you can say that this is the initial value of y. Okay, then we have another coefficient which is beta 1. Okay, now beta 1 is nothing but the slope. Okay, as you know, the equation of line, in that we have two parameters, one is intercept, another is slope. So this is slope parameter. Okay, anyone knows the formula of slope, how we calculate the slope in two dimensional? Okay,
Y is equal to mx plus c.
actually y equal to mx plus c is this. Okay, we just write this equation in terms of y equal to mx plus c only. Okay, yes. Okay, someone just in okay, see, this is a formula of slope, y2 minus y1 divided by x2 minus x1. Okay, and what is the interpretation of this slope? As we know, in 12 standard or in 11 standard, the interpretation of slope is nothing but the rate of change of y with respect to x. So in regression, okay, so basically beta 1 is nothing but the, see, suppose if x just changes by 1 unit, okay, then y changes by beta 1 units. Okay, that is the interpretation of this slope. Okay, means x is changes by 1 unit only, then y changes by beta 1 units. Okay, this is the interpretation of it. Okay, and in the last, see, we are gonna find out the error. Okay, how to find out the error? Error is nothing but the difference between actual value, your actual data point, and the predicted data point. See, I created the line, okay, by using this data point na. So after creating this regression line, so see, if I create a, if if I draw the one line which is perpendicular to the x-axis, okay, okay, by using the original data point, and at some point this dotted line just intersecting to the regression line. So see, at this point this dotted line just intersecting to this regression line, so this is nothing but my prediction value or the predicted value for this particular actual your data. Okay, so the difference between this actual data and the predicted data is nothing but the error value. Okay, likewise you can find out the error for each and every data point, okay, by using this regression line. See, so now these many things we can able to extract from this particular plot. Now for creating the linear regression model, okay, we have so many assumptions. Okay, like basically we have four main assumptions. First assumption is the linearity, means our parameter should be in a linear manner. Okay, then error should follows the normal distribution with zero mean and the standard deviation value, means the IID, means identically independent distributed. Okay, then the variance, means our error variance should be constant, means the equal variance, means the homoscedasticity. Okay, then here we have the assumptions about the predictions, like they should be non-random, because here we just find out the regression lines. So now we find out the each and every value of prediction. Okay, predict like predicted data point, we find out the predicted data points. So basically they are not random. Okay, now here we measured without error, and lastly linearly independent of each other. Okay, so as we make the prediction, so basically they are linearly independent of each other, and lastly assumption about the observations equally reliable. Okay, so as we know, all the data points are random, because we we I'm not just created data points, okay, by by uh, by myself. Okay, I got the data from client na, so all the data is nothing but the equally reliable. Okay, So here, before going to the before solving the business problem by using the simple linear regression as well as the multiple linear regression, let's go and solve one business problem using simple linear regression and one business problem using multiple linear regression. Basically, like in the like I just wanted to solve one business problem using multiple linear regression, but like to understand the multiple linear regression, simple linear regression is very important. So that's why we are solving first a business problem of simple linear regression and then business problem of multiple linear regression. So basically here you will see that the we have the data of waist circumferences and the adipose tissue. Okay, like most of the people, uh, many people are like dealing with one problem which is nothing but the obesity problem. Okay, and that obesity problem, okay, so with the people like those who are having the obesity, so they are they have a higher risk of cardiovascular diseases. Okay, so that's why first, okay, so we are just building the model for predicting the adipose tissues, okay, by using the waist circumference. So basically we have the data and of this waist circumference as well as the adipose tissue, okay, data of the multiple peoples. Okay, and here you can see that basically like to find out the adipose tissue area, okay, in the people, usually we are doing the CT scan, which is nothing but the computed tomography. Okay, and with the help of CT scan we can able to find out the precise and reliable measurement of the adipose tissue, okay, at any site in the body. Okay, but like there are some drawback or problem for with the using the CT scan. Okay, like many physicians do not have access to this technology and irradiation of the patient. Okay, like as you know, CT scan is equal to the one CT scan is equal to the 300 to 400 x-rays. Okay, so that's why it is a very like very high, it is provided very high radiation, okay, to the patient, and it is very expensive. Okay, for one CT scan we need three to more than 3,000, I think. Okay, and like in the opposite way, okay, if we find out the prediction model for finding out the AT area, means the adipose tissue area in the body, so like now it is it will be very simple. Okay, because it will be easily av- available as well as it is a risk free and inexpensive as well. Okay, so that's why let's go and build the simple linear regression model for this particular problem. Okay, so for that purpose again we have to use the Jupyter Notebook and see. So now here you can see that we have the data. Okay, and basically with the help of data we are just building the model of simple linear regression. Okay, and see here for that purpose first we are just importing the important libraries which are very much required to this particular analysis. So first and well-known library is nothing but the pandas library. Basically we are using this library for the data wrangling as well as to read the CSV file, to read the data. Okay, then second library is a numpy library. We use this library to create the n-dimensional array as well as for finding out some statistical analysis or for doing some statistical analysis. And lastly we are just importing matplotlib library for the data visualization. Okay, so let's run this cell. Okay, and after that, let's read the data by using the read underscore CSV, because here our data in the CSV format. That's why here we are using the read underscore CSV method to read our data. Okay, many times you will get the data in terms of CSV format. Okay, and here see, this is one attribute, okay, which is nothing but the columns attribute. You can find out the, or you can extract each and every column name in your data by using this columns, okay, attribute. And see, now here we are just using plt dot hist method, means here we are just plotting the histogram by using the matplotlib library. See, I used just here, I'm importing matplotlib library.pyplot as plt. Okay, so I store this library as plt, and see, I'm using this particular library, matplotlib library, for creating the histogram of this particular column in my data set. So basically in the data set, okay, let us see here. See, this is how our data set look like. So see here, I use the head method. Okay, so with the help of head method, I got the first 5 rows, okay, of my data. So see here, this is how our data look like. So first I have the waste column and another 80 column in my data set. So basically we are just using this waste column, and we are building the model using this waste column to find out this 80's value. Okay, so see here, I'm using the like this waste column, and I'm finding the histogram for this particular column. Okay, because first, like, there are multiple interpretations of histogram. First interpretation of histogram is nothing but the range. We can find out the range with the help of histogram. Okay, then another interpretation is we can find out the mode. Now here there are two mode, means we can say that the distribution of this data is the bimodal. Okay, means there are two mode in the data. Now see, now here we can't find out the shape, like where it is a symmetric distribution, where it is follows the positive or the negative distribution, because here we have two mode. Okay, so from the histogram we can find out, or we can get the insights. Okay, like first one is the range, then shape, and then mode. Okay, as well as you can just find out the kurtosis, means the, you can say that the uh, spread of your data. Okay, like see here, the spread of the data is not quite big, so you can say that like here we can't say that this is follows a leptokurtic distribution. Okay, because here we have two modes na? Okay, but we can say that here, now here we don't have any like higher tails. Okay, so that's why we can say that its tail is very short here. Now here with the help of matplotlib library, we are finding out the box plot. Okay, so basically we need this analysis, okay, to find out the like our regression analysis. Okay, like first we have to find out, are there any outliers or not. Okay, because outlier affect our regression line. Okay, so that's why we are just finding out the box plot as well as the histogram. So see, this is a horizontal histogram, and basically see, with the histogram, okay, we can get the like a range, then the quartile values, then the median value, then the lower whisker, upper whisker, so many things. Okay, by this one box plot. Okay, and see, we are just creating the histogram for our another column in the data set. So see, now 80 column is nothing but the positively skewed column, and this is a range of this 80 column. Okay, and here we have the one mode. Okay, and again we can find out the box plot of the 80 column. Now see, this is a vertical box plot, and this line is nothing but the median line here. This rectangle box is nothing but the like 50% observation is lies in this particular range. Okay, this particular range. See, so you can just say that you just use this third quartile and the first quartile and just subtract it, so you can find out the value as a IQR interquartile range, and you can say that 50% observations are lies in this particular range. Okay, this is a minimum value, this is a maximum value, this is a upper whisker, this is a lower whisker of the box plot. Okay, and lastly, see, here we are just creating the scatter plot. So basically after now here total, as we know, so many data points are there in our data. So basically see, after plotting the scatter plot, okay, so this is how our scatter plot of our data looks like. Okay, now you can add the labels, okay, for x-axis labels, for y-axis, as well as the title of your plot, which is a scatter plot. So see, I just add some title, okay, or the labels. So see, this is a scatter plot, I add the y label, I add the x label, and now you can visualize this scatter plot in a better way because you have the axis name. Okay, so can you guys tell me the type of this scatter plot? Okay, whether it is a positively skewed or a strong positively skewed or a moderate positively skewed or a negative skewed or a moderate negative skewed. Okay, anyone? Yes, it is a positive skewed, but like,
Moderative.
yes, absolutely, it is a moderate positive skewed, because see here data points are scattered, so that's why you can say that this is a moderate positive skewed. Data is going in upward direction, that's why you can say that this is a positive skewed. Okay, now you can find out the correlation value. Okay, now here with the help of this is my first column and this is my another column, and this is how you can find out the correlation value. Okay, in Python, so like there are alternative like alternate way for finding the correlation by using the numpy library as well. You can find out the correlation. Okay, see, this is the correlation value 0.8185, means you can just round off this correlation value by 2 decimals. So you can simply say that the correlation is 0.82, means the linear relationship between x and y is quite, you can say that the moderate one. Okay, and which is a positive here because here we have the positive value. Okay, and now see, again we are using the numpy library np. See here, okay, I store the numpy library, okay, as the np. So see, we are using numpy library and we are just using the core coef, means the correlation coefficient, and these are my two columns. Okay, so see, this is how we just find out the correlation value. This non-diagonal entries are nothing but the correlation value. Okay, so in simple word you can say that correlation between these two column is nothing but 0.82. Okay, and the diagonal values are always one for the correlation matrix. Okay, you will search for this, why these diagonal values are always one for the correlation matrix. Okay, now here you can see that we just use the stats model library, okay, to just use the one method which is most popular method for regression analysis, which is nothing but the ordinary least square. Okay, OLS. Okay, so I use stats model dot formula dot api and I store this as a smf, and I just extract or just import it the OLS, okay, from it, And simply here I just mentioned the formula y equivalent to x, means like I just wanted to find out the model for this particular AT by using this waste column, and this is my data. In that data we have these two columns. Okay, and after creating the model, okay, I'm fitting the model on my data. See, so I'm using this fit method to just fit the model on my like on the data. So see, now it is taking now it is just fitting the model on the data. Okay, and see, with the help of params, means the parameters, we can get the parameters of the model. Now see, we have two columns now, so that's why here we got the two parameters. Okay, in simple words, first one is a intercept parameter and second one is a slope parameter. Now we can simply say that, see here, I'm just opening my whiteboard so I can just note down the note down the regression equation. Okay, so see, basically this is the first intercept value and this is 3.45 is my slope value. Okay, and as we know, y value is nothing but the AT. So basically, okay, we have this simple linear regression model. Okay, okay, so see, basically this is a simple linear regression model, beta naught plus beta 1. Okay, so see, here we have this column. Okay, minus 215 plus 3.45, and here we have this waste, okay, column. So this is our simple linear regression equation. Okay, so now you can just put the any waste value here. Okay, and you will definitely get this value. Okay, which is nothing but the adipose tissue area value. So see, in simple words, with the help of ordinary least square, we just find out the equation. Okay, and this is a summary. Now summary of the model is very important, guys, because see, in on the data, okay, you are building the multiple models, but to find out which model is good or which model is best, okay, you need to check the summary. Okay, now in the summary, see, we have so many things. Okay, and this is the beauty of this stats model library. Okay, only by using the stats model library, okay, you will get this type of summary. Okay, see, now here we got the r square value, we got the adjusted r square value, f statistics, probability of f statistics, log likelihood value, Akaike's information criteria value, Bayesian information criteria value, as well as another table for finding out the significance for this particular column. Okay, each and every individual column in our analysis. So see, let's go like one by one with each and every evaluation matrix. So see, here first one is r square. Okay, r square is a 67.67, means the 67%. So basically interpretation of r square is nothing but the, there is a 67% of variation of your AT column, okay, explained by the your waste column. Okay, means in simple word, okay, let's say, okay, okay, if I know your one friend, okay, so I am extracting your information from your friend. Okay, so I got the 67% information of you, okay, from your friend. Okay, So this is the thing here. Okay, 80 and you can say that we have two columns in our data na? 80 and waste. Okay, see 80 and waste column in our data. So basically we are extracting the information, okay, from one column, okay, of the another column. Okay, so r square give us the that particular value, that percentage value, means how many percentage of information you just extracted, okay, for your output column, okay, by using your input column. Okay, now second thing is adjusted r square. Here adjusted r square is 0.667, means a 66.7, okay, percent. So basically when you are comparing your multiple models, okay, so which model is good? So first, by using r square you can simply say that this particular model is good in terms of r square. Let's say which r square, like value of which model, like r square value of which model is tends to 1, okay, or the highest, you can say that that particular model is good. Then second evaluation matrix is adjusted r square. Now here many a time you are just removing some column, or many time you are adding some columns in your regression model. Okay, let me show you here. Okay, let's say this is the first model, now this is the another model. Okay, beta naught, let's say beta 1 x1, okay, x plus beta 2 x2. Now this is a quadratic model. Okay, so I added this column here, okay, x square column. Okay, now I want to check that this particular column is giving any information or not about y. Okay, so with the help of r square, if r square is increased by adding particular column, new column in the model, so we can say that that particular column is important. Otherwise we can say that that particular column, new column, is not important. Okay, then we have another f statistics value as well as the p value for this f statistics. Okay, so basically uh, with the help of f statistics we find out the overall significance of the model, means model is significance or not for making the prediction about adipose tissue column or adipose tissue data. Okay, so if the probability value of this f statistics is less than 0.05, so you can say that your model is very much significant to making the prediction about AT. Okay, so here p value for this f statistics is 1.62 into e raised to minus 27, which means, okay, in short, this value is nothing but the 0.000 this many, 26 times 0, and then we have 0.162. Okay, so this is the value. Now this value is very much close to 0 na, and this value is also less than 0.05, so you can say that your model is significant to make the prediction about the, you can say that, AT column. Now you have the log likelihood value. If your log likelihood value is close to 0, okay, or you can say that which which model give you the log likelihood value which is very close to 0, then you can say that that particular model is good. Okay, okay, so now here log likelihood value is minus 534. Okay, now let's create multiple model to understand this values interpretation. Okay, then in the same way AIC and BIC, Akaike's information criteria and the Bayesian information criteria, with these two values, if these two values are less, or you can say that again tends to 0, so you can simply say that your model is good. Okay, so you just need to compare these values of different models to find out the best model. Okay, and this is the second table. Okay, so basically in the second table you will see the coefficient. Okay, you will see the coefficient for each and every column as well as the intercept, and you see the t value as well as a p value of this particular your t value. So you can say that, sorry, if your p value, okay, for your column, this is a independent column, na, waste column. You are building the model using this waste column for making the prediction about AT column. So see here, if p value is 0, which means this 0 value, as we know, this is less than 0.05. So which means this waste column is significant, okay, for, okay, for this analysis, okay. And now here we have the skewness, kurtosis, as well as the different statistical test, okay. Now I am just putting you this task that just go and search for this different hypothesis test, okay, and just check that how to, like, why we are using this thing here, okay. Because see, here we have so many summary of the model is there, okay. So now let's go and create another model. So basically I created here like 4 plus model, okay, by using the stats model library as well as the sklearn library, okay. I again repeat this thing by using the sklearn library. As we know, sklearn library is one of the like popular library for machine learning, so that's why I use that particular library as well, okay. So here basically we are just finding out the confidence interval, which is a 95% confidence interval for the parameters, okay, for checking the range of those parameter, okay. See, this is a 95% confidence interval for the parameters, okay. Now these parameters, okay, this confidence range can tell you the, like, your parameters, it should be in this range, okay. Then you can make the predictions by using your model, okay. Basically this is your model, na? This is your model, okay. So you are using this model to make the predictions. So in Python we are just using this model dot predict method. See, I just use this small 2 words. First I just created model using the data, and I'm making the predictions, okay. So see, I just use this method to find out the predictions, okay. So see, this is how our predicted values looks like, okay. Now we have the original value, means the actual data point. We have the predicted value. So in simple manner we are just creating the scatter plot. See here, first I'm creating the scatter plot, okay, with data points in a red color, okay. And here I am drawing the one line of regression, and again I am mentioning the X label, Y label, okay. So let's run this. Now see, now you can see the original data points and the predicted data point here, okay. This black line is nothing but the regression line, okay, I created by using the ordinal least square method. And here you can see the data points in the red color, okay. Now basically you can find out the correlation, okay. Now see here, the correlation between the predicted value and the original value is 0.82, which means, okay, now there is a relationship between the correlation and the, you can say that, the R square value. So see, basically, like, R square value is equal to the correlation square, okay, because as we know, correlation means R, and like, this is a relationship between the coefficient of determination and the correlation coefficient, okay. So see, by just simply finding out the correlation coefficient, okay, you can imagine, and you can try to just say that your R square value is good or not, okay. See here, correlation value 0.82, so you can say that yes, like, if you find out the square of this value, so this may give you the value as a 0.67, okay. So you can check that one as well. Okay, so you can say that r square is nothing but the 0.67. Okay, so now you can just make the conclusion of your model, okay, by using correlation as well. Okay, now see, now I am just transforming the data. Okay, which data? Input data only, not the output data. Okay, I'm just transforming the input data to find out, or to find out the like, to get the better accuracy of the like, or the models, different models with the better accuracy. And see, again here I'm using the ordinal least square regression. Okay, and see, I'm applying the log, okay, on x. Okay, means now here this is a regression of the logarithmic, means you can say that this is a logarithmic regression. Okay, now first we got the linear regression, now we are finding out the non-linear regression. Okay, yes, any questions? Okay, so see, after finding out the like logarithmic regression, so see, these are the parameters of this regression equation. Okay, so let us check the summary of the model. Okay, see, first I got the r square value as a 0.67, means 67%, and the adjusted r square is a 66.7%. So see here, now r square value is little bit increased. Okay, as well as adjusted r square value is also little bit increased, which means this changes is bit good. Okay, means we are just converting our data, okay, to get the better accuracy. And now you can see the difference between the log likelihood for your first model and this model, okay, as well as AIC and BIC. Okay, see, this is the log likelihood for your first model minus 534, and this AIC value 1074, BIC value 1079. Now you see the little change in log likelihood as well as AIC and BIC. See, in AIC you will see a very little change in log likelihood. Okay, in points I think, and in AIC and in BIC, in AIC there is a 2 point difference. Okay, first you got the AIC value as a 1700 uh, 1074, and BIC value as a 1079. Here you got the AIC value as a 1072 and the BIC value as a 1007, oh sorry, 1078. Okay, and see again, your individual column is again showing you the significance. Okay, so you can consider this model as well. Now you can create another model. Okay, so before that, okay, you can just run this and find out the confidence interval. Okay, you can find out the confidence interval of 99% or the 95%, depends on you. Okay, and again you can just make the predictions and you can find out the correlation value. Now see, there is a little increment in the correlation value. Okay, and you can find out the scatter plot. Okay, now you see the we transform data from linear to non-linear. Okay, see, there is a non-linear pattern is there. Okay, and now here we are just building the exponential regression model. So basically, for if I use the exponential, if I apply exponential term on waste, so you just try to imagine this exponential term. If you just add the like 2 square, okay, then 2 raised to 5, 2 raised to 10, if you increase the like the order term, okay, so then you will get the value in billions, in trillions. Okay, if you add the like, if you use exponential term here, okay, e raised to 107, So try to imagine those values. Okay, so instead of applying exponential term, let me apply the log term on the y first, and then we can able to transform, okay, by using this. Okay, because as we know, see, if let's say if I use this log of y term here, and this is beta naught plus beta 1, okay, this thing, okay, x, then if I use exponential term, so definitely this exponential and log cancel out, and then we remain with this y term, and we add the exponential term here. Okay, so that's why we just use we just apply the log term here, because log values are like mostly in the negative values and very close to, you can say that, in a points. Okay, so that's why we are just applying the exponential term, first log term here, and then we are converting logarithm, this log term into the exponential term. So see, this is the summary of the model. Now see the summary. Okay, r square is now 70.7%. Okay, 0.7. See, okay, in the first here we got the r square as a 0.67. Okay, means only say 67%. In the second we got the r square as a 67.5%, and in the exponential we got the r square as a 70.7%. You see the increment. Okay, as well as the adjusted r square is also increased. Okay, then see, the p value is very close to 0 now. Now see the difference, log likelihood minus 40.123. So we just change the log likelihood from 100 to only two decimal points. See here, we just convert this log likelihood from 500 minus 534 to only minus 40. So see the change. Okay, as well as we just change the log likelihood from 1000, okay, to 84, as well as BIC value from 1078 to 89. Okay, so you can just now imagine how we like get the better model if we transform the data. Okay, and see here p value is 0, so you can say that this column is a significant column. Okay, so you can make the predictions. Now this is the predictions in the form of log. Okay, because here I just add the log for y term. Okay, for the outcome column na. So that's why here now I am applying exponential term here. Okay, after applying exponential term, see, now we get the original y value. Okay, see, first we have this type of y value, now we have the y values in terms of 2 digits. Okay, so now we can just find out the correlation. Okay, remember guys, we are not checking the linear relationship here, we are checking the non, because here we are applying the exponential term, so that's why this is a non-linear regression now. Okay, I am using correlation here to show you, like, instead of, like, if you haven't, like, if you do not have this summary, okay, to find out the r square value, so the simplest way to find out the r square value is to find out the correlation and apply square on it. Okay, so then only you can find out the r square value in simple way. Okay, so if you find out the square, so you can simply get the r square values. Okay, and then you can easily make your predictions about like by using the r square value, which is nothing but 0.707. See, and now you see now here, now data is very non-linear or curvilinear pattern. Okay, now here instead of this one curve, I got this many line here because of the data is not in the, like, is not in a time series manner. Okay, so that's why here we got this multiple lines. Okay, and I, like, here intention is to show you how to just use the exponential regression and how to apply exponential regression on this data. Okay, now you can find out the like residual analysis here. Okay, so first, to apply residual analysis or to do residual analysis of your data, first you need residuals, means the error term. And see here, this is nothing but the residuals. Okay, means you can say that the error actual minus predicted values. Okay, and see, this is the basically the residual analysis. This is a simple plot of the standardized residual. Okay, if you can say that if this data is randomly scattered and which is parallel to your x-axis, so you can simply say that your error, okay, are just, you can say that the independent one. Okay, like I have this. Okay, so means you can say that your model is adequate. Okay, so you can just like prove the one assumptions, okay, about the error. Now you can just create the one plot which is nothing but the your predicted values and the, you can say that the actual data points. Okay, and see, then we can apply the another quadratic regression model. Okay, now here let's see, here we just added one square term here. So basically by adding the square term here, so see, again I use the ordinary square, and here I mention these two term because see here, this is the same term. Okay, this is a x square term here, means here I'm using this square term, okay, to get the model. Okay, now we have two different parameters, so let's see the summary first. Now summary is you can say that is good as compared to linear and the logarithmic model, but is not good as compared to exponential, our previous model. Okay, which is a exponential model. Here we got the summary as a r square as a 70%. Okay, but here we got the r square as the 67.8%. Okay, now you see again the some increment in the log likelihood AIC BIC value. Okay, now here you can make the predictions now by using the quadratic equation, and you can also make the plot. Now here we have the two columns, so that's why we are just creating the plot for like for using the two columns. Okay, not the three columns, because here we have the three different columns na, waste square and the original AT column, which is output column. So that's why we are just using the AT and waste column to find out the regression line. Okay, if you just create this regression plot or the regression equation in the 3 dimension, you will get the plane. Okay, and see again, this is the residual analysis. Basically this is randomly scattered, so you can say that your data is nothing but the uh, you can say that the independent. Okay, means like IID normal, and you can find out the data distribution, okay, of or the distribution of the residual, means your error. So you can simply here find out the histogram, or you can go ahead with the normal probability plot. Okay, you have different ways, okay, to check your data follows a normal distribution or not. Okay, if you find out the curve, so simply you will see that it's slightly showing you it follows a normal distribution. Okay, so this assumption satisfied. Now see here, here I created the code for implementing the linear regression model, okay, by using the sklearn library. But here I'm just like sharing this code with you, and let's go with the multiple linear regression. Okay, because here this both code are the same, but I use the like different library to show you the like how to use stats model, okay, for linear regression, as well as how to use stats model for the uh, how to use sklearn library for the linear regression. Okay, so let's go and solve the business problem of the multiple linear regression. So basically business problem of the multiple linear regression is basically here our aim is to build the model for mpg, means nothing but average miles per gallon, okay, of a car based on the other different variables in our data. Okay, so here you will see that we are using the cars data set. We have total 81 observations in our data. This is a small data set because is like my intention is to show you how to implement ml, okay, the multiple linear regression on the real life data set. You can use any number of data points in your data, as well as any number of columns in your data. Okay, so see, in my data set I have 5 columns. Okay, volume, okay, this vol, okay, cubic feet of cap space, then we have the hp means engine horsepower, then we have the mpg means average miles per gallon, then we have sp top speed miles per hour, then we have weight, vehicle weight. Okay, so then let's go and build the multiple linear regression model. Okay, so see, now you can see that here again we are just using the three main library, which are very basic and important library for our analysis. Or even if you are using like applying ml on any data set, so you have to use these three libraries. Okay, first pandas to read the data, as well as it's a library for the data wrangling as well as the data analysis. Then for creating n-dimensional arrays as well as for doing some statistical analysis, you need to apply numpy library. And finally for the data visualization, okay, you have to use matplotlib library. So for that purpose, let's go and import these libraries. Okay, and after that let's read the cars, okay, csv. So basically here with the head method, now I am just adding like here the 15 value, which means I want to see the top 15 rows of my data set. Okay, so see, this is how our data set look like. We have the hp column, mpg, vol, sp and weight column. Okay, and this is how our data looks like. Basically in our data all the columns are numeric, okay, and all the columns are continuous one. So now let's go and create the confusion matrix. Basically we are creating the confusion matrix is to find out the like is to check one assumption, and one assumption is nothing but the all the columns should be like all the input columns should be independent. Okay, so and as we know, okay, we are just saying that input data is nothing but the column. Okay, in that all column are the independent columns, and those column are just dependent to one column, which is the target column or the output column. Okay, so see, we created the correlation matrix. Now see, all the diagonal values are 1. Okay, because correlation with itself is always 1. Okay, you know about yourself 100%. So this is a interpretation of this diagonal value 1. Okay, and this non-diagonal values are lies between -1 to +1. So see, some values like some correlation between like data points is nothing but the -0.72, which is a correlation between mpg and horsepower. And then again there is a correlation between volume and hp. But see here, this is a very small correlation, means you can say that correlation always give you a value, any value, okay, in between -1 to +1. But you can able to interpret that particular value, because here in regression equation one assumption is nothing but the input data should be independent to each other. Okay, so that's why, as we know, HP, volume, SP and weight should be independent to each other. So you see two columns showing us a high correlation, which are input column, but they are showing a high correlation. So this is a problem of multi-collinearity. Okay, in advanced statistics you will learn this thing, multi-collinearity. Okay, so many a time while just solving the regression task, okay, you may face this problem. Okay, which is nothing but the, you can say that the multi-collinearity. Okay, and this is a very like, you can say that very big problem in the regression analysis. So you have to overcome this problem. Okay, now see here, first column, first two column is nothing but SP and HP. Okay, which is showing a 0.97%. Okay, 0.97 means the, here 0.97 is a correlation between two independent columns. Okay, they are showing us a positive, strong positive correlation, as well as see here weight and volume. Okay, these two columns are showing a very high correlation. Okay, so see, HP and SP and volume and weight. So now here you can visualize this, okay, correlation matrix, okay, by using the scatter plots. Okay, so you can create the scatter plot by using the Seaborn library, see, with the help of pair plot. So let's run this and then see how we just try to create the different plots of these variables. Okay, so here we just created the scatter plot matrix, and each diagonal value or each diagonal plot, here you can see the plot is nothing but the, see, the histogram. Okay, because all are the continuous column. Okay, so see, this is a histogram, but here our intention is to find out, is there any two column which are input column showing a dependency, okay, on each other. So see, this is the first column. Okay, this is the first two column, volume and weight. Another column is the SP and the HP. See, this is also a high strong correlation, and this is very strong correlation. See, all data points in a one line, and they are making a very strong correlation, volume and weight. Okay, so let's go and just solve this multicollinearity problem. Okay, so for that purpose, first we have to extract the column names, okay, to build the formula, okay, for our model. Okay, like many a time we may have like multiple columns, or the like n columns, let's say 100 and 1000. So in that case as well, we have to build the formula. Okay, so see, again here we are using the stats model library, and again ordinal least square. Okay, so see here, our output column is the mpg column, and remaining four columns are nothing but the input column. Okay, so first in the initial part we are just building this multiple linear regression model without any transformation. Okay, and let's see the parameter as well as the summary of the model. Okay, so see, these are the parameter. Now we have the four columns which are the input column. That's why total we have the four coefficients. We can say that these are the slope coefficients, and first we have the intercept column. Okay, sorry. So see, the summary of the model is a 77%, adjusted R square is a 75%, and all this stuff, probability value is a quite tends to zero, like p value for f statistics is quite tends to zero. Okay, then the log likelihood AIC BIC. Okay, so we are going to use this log likelihood AIC and BIC value by for comparing multiple equations of multiple linear regression. Okay, now now most importantly, this is the second table. Okay, now here in the multiple linear regression, okay, we are building the model using the multiple columns na? So that's why this table, this second table is very much important. Okay, so see now the p value. Okay, for weight column, p value is 0.814. Okay, so you can say that this column is a insignificant column. Okay, again, volume column, this column is also insignificant, 0.556. Basically, in general, this p value for each and every individual column, okay, it should be less than 0.05. Okay, if these values, this p values is greater than 0.05, then those columns are showing the insignificantness. Okay, so now we'll do one thing, we'll go and try to build a model using those insignificant columns. Okay, first here I'm using the volume column. Okay, and I'm creating the simple linear regression, and I'm checking that that particular column is making the this if I use that single column, then this column is significant or not. So see, now p value is 0. Okay, in the initial part, in the first part, okay, p value is 0.556. Okay, now if I use this volume column separately individually, so see the p value is 0, which means you can say that now this is a significant column. If you use this column individually, okay, here our intention is to check the significanceness of the volume column only, not the r square, not to check the this value r square adjusted r square and other values. Okay, only this term. Now again, let us create the simple linear regression by using the weight column. Okay, now see here, here also, if I use weight column separately and I created the regression model by using this column only, so p value is 0. Means this column is also significant. But what if I use this column together in the analysis? So let us run this. See, I use these two column in my analysis. So now you can see the p value for both the column is greater than 0.05. Okay, one. Okay, this p value for weight column is 0.626 and p value for the volume column is 0.480. Okay, now you see, now both column are showing you the insignificantness. Okay, so that is the difference. Okay, so now again, go and check that what are the different data points which are showing the influence in your analysis. Okay, so let us go and build the influence plot, okay, by using stats model library. So see, after using the influence plot in the multiple linear regression, so see, we are just finding out the weightage of particular each and every data point in our data set. Okay, actually this is taking some time. Okay, so now see, this is the influence plot. Okay, actually I don't know why this is giving a two different plots. Okay, but I can just say that this is a buy one get one, okay, type thing. Okay, by using the stats model, if you use the stats model library. Okay, so see, this is the influence plot. Okay, I created, means I am creating the plot for checking that the each and every data points weightage, okay, for creating my model. So see, now if I use this influence plot, so see, data points with index number 76 is having the highest weightage in my model, as well as the data points with index 70 is also having a highest weightage, okay, in my model. So as we know, this highest weightage, I don't want these points, okay, because they are influencing my model. Okay, they are not like, they are just giving the bad model, not the good model. Okay, so that's why let's go and drop those data point, okay, from overall data set. So see, I am just using my original data set, I am dropping this, okay, only those two data points with index value as a 76 and the 70 with axis equal to 0 means just drop the row value, not the column value. Axis equal to 1, just drop the index column, okay, with 76 and 70. If you mention here axis equal to 1, so I mention here axis equal to 0, so that's why I'm dropping the row, okay, instead of column. So after dropping the row, two rows, now let's go and again build the regression model by using all the columns and see is there any change happen or not. So this is a parameters and this is a summary. So again, now see the r square is quite increased. Okay, now basically in the previous, okay, in the initial part, if I, okay, I created one model, multiple linear regression model using all the columns, and see the r square 0.77 means the 77%. But here I used I just dropped two data points and I got the r square value as a 0.816, means near about 82%. See the increment, okay, by just dropping two columns with index 76 and 70. So this is a advantage of using this influence by checking this influence plot. Okay, now see, after this you see, like after getting the r square value as well as adjusted r square value is good, but here p value is not good na. So means they are saying that this particular column as well as this column is not significant. Okay, so now let's go and drop this particular column and let's see the again summary of the model. Okay, because this is giving a highest p value. Okay, so here this is again the predicted. Okay, so let's go and drop the, now I just drop the one column which is a volume, which is a weight column. See here and here, sorry. So basically, like before dropping the column, we have to check VIF values. Okay, because there are several terms like influential plot. Then we have the VIF value, variance, inflation factor. Okay, we have to check those factors too. Okay, along with the r square adjusted r square value, and then we'll go and simply drop that particular column. Okay, so let's go and find out the VIF value. Okay, so in short, if VIF value is small, your model is good. Okay, now see the VIF value for each and every column. Okay, now see, these two columns are giving you the highest VIF value. Okay, but weight column is giving you the highest, okay, VIF value. Okay, so now let's go and drop the weight column. Okay, because see here in the added variable plot, this gives a partial correlation, okay, partial regression plot. See, if you just find out this term, so this weight column, okay, this giving you a very parallel plot, okay, which is very much parallel to your x-axis. Okay, so you can't say that this particular plot, okay, is finding the relationship, because if the data point which is data, the regression line which is very much parallel to the x-axis, so you can say that that particular line is not good, or you can simply say that your data is a constant in that case, because your line is parallel to x-axis, so your data is always constant, not increasing, not decreasing. Okay, so see, remaining columns are showing you the regression term is there, like they are the downward, some are showing you the upward pattern is there. Okay, but only two column, weight column and volume column, is not showing you the like this downward and upward part. okay, because of this VIF value. See, VIF value for these both two columns. So let's go and first just drop this weight column. Okay, so see, I created the regression line, or sorry, multiple linear regression by using only three columns. Okay, volume, SP and HP. Okay, let's run this and find out the summary. Now see the summary. Now the p value for each and every column is less than, you can say that point not 5. So you can say that now you got the model. Okay, and now you can make the predictions. Okay, because like R square, adjusted R square are important, as well as VIF, influence plot is also important, but most importantly, okay, all columns, all input columns should be, you can say that, should be independent, or should be making the significance contribution for creating the model. Okay, then only you can go ahead with those column. Okay, if those column, if one of the column is showing the insignificant contribution for making the model, so why to go with that particular model? Okay, just go remove that particular model and go with the like our further analysis. Okay, now let's see, like I just, now we have all the significant columns. Now let's go and again find out the partial regression plot. Now see the difference. Now see this, like I like using this SM like stats model, I got the two plots, okay, which are same, like buy one get one. So see here in the first four plot, you see the now partial regression plot is showing a like a significance. Okay, now you can check the assumptions, okay, of the regression. So see, first the linear assumption. Okay, now basically you can like we created the model, okay, without any transformation, we just drop the one column. Okay, now we just created, you can see that the observed value and the fitted value, okay, mean the original value and the, you can say that the predicted value. So it is you can say that little bit curvature manner. Okay, but you can make the linear regression, okay, for this plot as well. Okay, so this is a very you can say that very slightly curvature. Okay, now you can go ahead and check the normality assumptions, okay, by using the histogram. Okay, or you can even make the probability plot, means a normal probability plot. See, now here this plot is very much important. Okay, basically most of the people or the like professionals are using the this normal probability plot for checking the sorry, this data is follows a normal distribution or not. Okay, so you can say that the data points are very much close to this line, so you can simply say that your data follows a normal distribution. Otherwise you can say that your data not follows a normal distribution. So this is the interpretation of the normal probability plot. Or even with this histogram, you can say that if you just find out the curve, so you can say that this particular histogram, okay, from this distribution histogram, you can say that data distribution is normal, slightly normal. Okay, because if you just find out the curve, then you will understand. Okay, then you can say that the third assumption is the equal variance homoscedasticity assumption. So here you can see that by finding out this residual analysis plot, so you can say that your data is randomly scattered. Okay, so you can say that your variance of your error is equal. Okay, now here again, as I created the code, okay, by using the sklearn library. So here also I use the sklearn library. See, I use a model selection, means here I am splitting the data into training and testing data set. Okay, with test size as a 20% of overall data, and the train size as a 80% of overall data. Now what is train and what is test, and why we are splitting the data? because many time, as we know, if we build a model on overall data set, okay, then how to check, how to make the predictions for like for new data, okay, because client just provided us this particular data set, okay, and like the client wants to find out the best model, okay, for the prediction, okay. So now we have to split the data into training and testing data set. With the help of train, we are building the model, okay. So the test data is the unseen data for the model, because we created the model using the train data na? So then we are just applying that particular model on the test data and see what is the accuracy, what is the different evaluation matrices, okay. So let's go and import first train underscore test underscore split method and just split the data, okay. So see, here we are using the sklearn library, okay. So in the tomorrow's sessions, overall we are using the sklearn library for applying the classification method on the data, okay. And see, we use the three columns which are significant columns instead of weight column. And see, here I just created one model, okay. I make the predictions using the train data for checking the accuracy or the goodness of the model, okay, on the train data itself, okay. And then find out the RMSE. Now what is RMSE here? Basically RMSE is nothing but the residual mean square error. This is another evaluation matrix for you can say that for checking the goodness of regression equation, okay. So let's run this. So now train RMSE is 3.88, okay. So you can say that it's just take the round of this value as a 3.88 by 2 decimal points, okay. And now see, here we are applying our model which we were built by using the train data, and we are applying on the test data, which is a very new data to the model, okay. And then we are finding out the error as well as the residual mean square error, okay. So see, the residual mean square error, which is quite similar to this value, the RMSE value of the train. So you can say that there is no much difference between the training RMSE as well as the testing RMSE. So you can simply say that this model is quite good model, okay. And see, here we just use the sklearn library, okay. And as we know, we already did all the transformation, okay, and we already found that all the influence plot, okay. And here, as we got the three columns which are making the significance for creating the model of MPG, so that's why we just use here MPG, okay, this three column for building the model for MPG column. And see, here we are using the sklearn import underscore linear model, means here we are just importing this linear regression method, okay. So see, we are after building the model, we are just fitting the model on our data X and Y. So now you can see we just split the data into input data set and the output data set. So see, we just split the data set here. This is very important, guys. So in the cars data set, we have total 5 columns. One column is insignificant. We drop that particular column. So that's why we just use these 3 columns in the input data set, and this is output data set. And now we are using input data set and the output data set to find out the model. And these are the coefficient and the intercept. See, these three are the coefficient for each and every column, these 3 column respectively. And lastly, here we have the intercept value, okay. And we can simply make the predictions, okay, using our model. This is how our predictions looks like, and you can find out the R square, okay, by using the score method. See, R square is 0.77, okay, means the 77% variation of this Y column, means this MPG column, is explained by these 3 columns, okay. So this is how you can able to apply multiple linear regression on your data.